Hello everyone, welcome to our adventure on the solenoid actuator. Actuators are very useful devices and have a wide applications in our daily life, such as automotive and aerospace industry. In order to give you a better understanding of what is solenoid actuator, I will introduce our lectures by the following 6 points. Firstly, I want to ask you one question. Do you know what is an actuator? Simply, actuator is a device that can make something move or operate. So according to this definition, have you found any actuator in our daily life? Let me give you a good example. In the food market or grocery store, the automatic door is controlled and moved by an actuator. Another example is that the backwards and forwards movement of the car seat is also achieved by an actuator. So in our daily life, every one of us takes advantage of at least one actuator every day. So what type of actuator do you know? So actuator converts a source of energy into a physical mechanical motion. And according to the different types of energy they use, we can divide the actuator into 3 different types. The first type is pneumatic actuator, which are operated by compressed air. The second type is hydraulic actuators, which use a variety of liquid as a source of energy. The third type is electric actuator, which is operated by some form of electricity energy. And in our lecture today, we will focus on the electrical actuator. The picture below shows 2 common types of solenoid actuator. The first one is electrical solenoid actuator, and the second one is magnetostrictive solenoid actuator. Our lecture today will focus on the electrical solenoid actuator, and in our future lectures, we will discuss more about magnetostrictive solenoid actuator. So I want to ask you to discuss in groups what drives the solenoid actuator. So the mechanism is not difficult. Let's take at its configuration first. The actuator consists of a solenoid coil winding, and stator iron core, we call it case or frame, a movable plunger, as well as a spring, and the end of the plunger is attached to the spring. So when a current is put into the solenoid coil winding, a magnetic flux will be generated, which passes through the iron core and air gap. We call it May flux. However, a small part of magnetic flux will also be generated, but which doesn't pass through the iron core. We call it leakage flux. The May flux plays a role converting the energy of electrical and magnetic into physical mechanical motion, which will generate the magnetic force and drives the plunger to the center of the solenoid. If you are interested about how this formula of the magnetic force comes about, you can deduce this formula by yourself after class, and this will be your first after-class assignment. So can you imagine when the solenoid actuator connected to a DC supply, how it will work or operate? So let me explain it by an animation. When the current is on, the solenoid coil winding will generate magnetic force, driving the plunger to the center of the solenoid coil, and it will compress the spring, and an energy of a mechanical will be stored in the spring. And when the power is off, the spring will release the mechanical energy and push the plunger to the initial position. So here, let's analyze the forces of the solenoid actuator during the mechanical movement. In order to simplify our models, we make several assumptions. The first one is the actuator is subjected to a constant load force, F load. Second, the plunger is subjected to a constant friction force, FF. Third, the mass of the plunger and the spring are very small and can be neglected. So under these assumptions, we will find the magnetic force F has to overcome three different mechanic forces. The first one is elastic force generated by the spring. The second one is friction force. And third one is the load force generated by the external load. And when the power is off, the spring will generate an elastic force, Kx, which pushes the plunger back to its initial position. So based on what we have learned about the operation and the mechanism of the solenoid actuator discussed in above slides, we can simplify our solenoid actuator into a model with three different domains. One is electrical domain, another is the magnetic domain, and the third one is the mechanical domain. In the first electrical domain, the solenoid coil has a resistance R and a reductance L. In the magnetic domain, the solenoid coil winding, which is powered by the DC current, will generate a magnetomotive force Ni. And this magnetomotive force Ni will generate a magnetic flux flowing through the L gap and iron core. So in this model, we make two assumptions. The first one is the leakage is very small, and which can be ignored. Second, there's no magnetic saturation in the iron core. And under these two assumptions, there are two major reluctances generated by the iron core and L gap, that is R iron and R air. And we have to know that since the permeability of the iron core is much higher than that of the L gap, so the reluctance of the iron core is significantly smaller than that of L gap. So the third model is the mechanical model. In this model, we have already made several assumptions we have mentioned above. And in this model, you will find the magnetic force F has to overcome three different kinds of mechanic force. One is the elastic force generated by the spring. Another is the friction force, FF. And the final one is the load force, F load. So from the model we described in this slide, we can clearly see that the energy was transferred from electric domain to magnetic domain and finally to a mechanical domain. And here I want to ask you one question. Can you find any energy loss during this process? Okay, let me show you the answer by using this energy flow diagram. So firstly, the electric energy was input by the power supply, and a part of energy will be consumed by the resistance of the solenoid coil. We call it resistive loss. And the rest of the electric energy will be converted to magnetic energy. Energy transfer efficiency of the magnetic energy into mechanic energy is quite high, and we can regard it as close to 100%. And most of the mechanic energy will be transferred to the movement of the mechanical load, and this is an effective output of the mechanical energy. But some part of the mechanical energy will be consumed by the friction force. We call it friction loss. And another part of mechanical energy will be stored in the spring. We call it elastic potential energy. And this energy will be finally consumed and released during the recovery process of the actuator. So, based on what we have learned in this lecture, I will give you two in-class exercises. The first one is, if you have an actuator with the following parameters, so how big a magnetic force can be generated? You can think about it. Okay, this is the answer. So, firstly, you can use the magnetic model to calculate magnetic flux phi. And then you can use the value of the phi to calculate the magnetic force by using our formulas. So here the result is around 62 Newton. And this force can use to lift up object weighing about 6 kilograms, which equals to the weight of the small dog. And this solenoid actuator can be used in the valve in our factories. So I want to ask you a first question. You can think about it after class. So how much current is required to generate a force, a magnetic force of about 100 Newton? Okay, our second in-class question is, according to the energy transfer diagram above, can you give the formula of the energy transfer efficiency of the solenoid actuator? Okay, the answer is here. You can get this answer by reviewing the slides showing the energy transfer diagram. Okay, now let me give you a brief summary of what we have learned today. Firstly, solenoid actuator is a device that can convert a source of electric energy into a physical mechanical motion of the external load. Second, the equivalent model in 3 domains shows the operation and the mechanism of the solenoid actuator. Third, the energy flow diagram shows the energy transfer mechanism of the solenoid actuator. And in this energy transfer process, you will find a resistive loss, a friction loss, as well as an elastic potential energy loss in the spring. So here are also 2 off-class assignments for you. First, you can deduce the formula of the magnetic force F. Second, think about how the electrosolenoid actuator works when it is connected to an AC supply instead of DC supply. And then below are some reading reference for you. Okay, that's all for today's listening, and thank you all.